Hi, this is Mrs. Rodriguez, your algebra teacher. This video is a review for the Chapter 9 quiz that's coming up. What I recommend that you do is that you have some paper and something to write with. And when a problem comes up on the board, pause the video, try to solve the problem yourself, and then play the video. If you get the answer correct, great, move on to the next problem. If you get the answer wrong, hopefully my explanation makes sense to you and you can figure out what your mistake was. If you get to the end of the video and there's some problems that you just don't understand how you got wrong, or you don't understand my explanation, please call, email, text, stop by my office hours so we can discuss those problems, okay, before you take the quiz, okay? All right, let's go ahead and get started. I'm going to share my screen with you. So like I said, this is the review for the Chapter 9 quiz that's coming up, okay? So the first section talks about quadratic functions. They're non-linear and they can be written as f of x is equal to ax squared plus bx plus c, where a is not equal to 0. And this form is called standard form of a quadratic function. And the shape that these functions make are parabolas, okay? And parabolas are symmetric about a central line called this axis of symmetry. So this line cuts the parabola in half, directly in half. And then the axis of symmetry intersects the parabola at only one point called the vertex. So that point, that's what's called the vertex. And then to find the axis of symmetry, we use this equation here, okay? And so we can have maximum or minimum values depending on what a parabola looks like. So if we have a parabola that's opening upward, then our vertex is going to be the minimum value, okay? Makes sense because that's the lowest point on the graph. We don't know the highest point because the highest point keeps going, right? Keeps going in both directions. And so if our parabola is opening downward, then we have a maximum value because there's a certain point that in the f of x will not go higher than, okay? Or on the y-axis, it will not go higher than a certain point, okay? So the way we graph quadratic functions is first that we need to find the equation of the axis of symmetry. We then find the vertex to determine whether it's maximum or minimum value. Then we can find the y-intercept, and we can use symmetry to find additional points on the graph if necessary, and then connect the points with a smooth curve. All right, so let's try that. It says first we have to write the equation of the axis of symmetry. So remember that equation is negative b over 2a. So here, if it's written in standard form, a is equal to 1, b is equal to -5, and c is equal to 4, okay? So for our axis of symmetry, this should be x equals negative b over 2a. We have x equals negative, and in this case, b is -5, and then over 2 times a, which is 1, okay? So we have negative times -5 is going to be a positive 5, and 2 times 1 is 2. So we would say that x is equal to 2.5, okay? So that means that at positive 2.5 is our axis of symmetry. So we would have this line here. Okay, that's going to cut the parabola in half. And then we need to find the vertex, okay? So we're going to plug in this 2.5 in for our original equation, okay? So we have y, maybe a different color. Y is equal to 2.5 squared, and I'm just using the original equation and plugging in 2.5 for x plus 4, okay? So if I square, use order of operations, you have to do exponents first. So 2.5 squared is 6 and 25 hundredths. minus 5 times 2.5 plus 4. Then I would multiply. So I have 6 and 25 minus 5 times 2.5, which would be 12.5 plus 4. Then if I subtract 6 and 25 minus 12.5, I get negative 6 and 25 and I still need to add a 4. And when I do that, y is equal to negative 2 and 25 So that means that the vertex is equal to, we have our x value of 2.5 and our y value of negative 2 and 25 hundredths, okay? So that point would be, here, this is positive 2.5, so I'd go down 1, 2 1/4, which would be about right there, okay? So that's the vertex, okay? So then what I need to do is find the y-intercept, okay? So the y-intercept is when x is equal, when y is equal to 0, okay? So I'm going to set my equation y equals x squared minus 5x plus 4. I'm going to set that equal to 0, okay? And then, so I have 0 equals x squared minus 5x plus 4. Well, I can factor that, okay? So the factors of 4 that add up to negative 5 would be negative 4 times negative 1 would give me positive 4, and negative 4 plus negative 1 would give me negative 5. So I have x minus 4 equals 0 and x minus 1 equals 0. So I would add 4 to both sides. So x is equal to positive 4. Here I would add 1 to both sides. So x equals 1. So I have a point at x equals positive 1. So a point here. And okay, and then I have a point at x equals positive 4. So that's 1, 2, 3, 4. So my parabola, and try to connect this with a smooth curve, is going to look something like this, and then this side would be something like that. Okay, so then we have our graph. Okay, all right. So the next section says to solve by graphing. So a quadratic equation can be written in standard form. And to write a quadratic function as an equation, you replace y or f of x with 0. Okay. And then recall that solutions or roots of an equation can be identified by finding x-intercepts. Okay. All right. So when you solve an equation by graphing, remember the solutions are where it crosses the x, where the parabola crosses the x-axis. So one of three things can happen. You can have two real solutions because the parabola crosses the x-axis at two different points. Another thing that could happen is the vertex of the graph is right on the x-axis. So there's only one solution, okay? And then the other thing that can happen is that your graph could never cross the x-axis. It's either above the x-axis or below the x-axis, and then it never crosses the x-axis, okay? All right. So question number 9 here says to solve each equation by graphing. If integral roots cannot be found, estimate the roots to the nearest 10th. Okay, so here I'm going to go ahead and first use the axis of symmetry equation to find the, well, actually first I'm going to factor this, okay, because this is factorable. So the factors of 6 that add up to 5 would be 2 and 3, right? 2 times 3 would be 6, and then 2 plus 3 is equal to 5. So then I would do set x plus 2 equal to 0 and x plus 3 equal to 0. And then I would solve by subtracting 2 on this side. So x is negative 2. And then subtract 3 on this side, and x is negative 3. So I have a point at x equals negative 3. X equals negative 2, and also a point at x equals negative 3. Okay. Then I need to find my vertex. Okay. So first thing when I'm trying to find my vertex is I need the axis of symmetry. So remember that's x equals negative b over 2a. So x is equal to negative b, which is 5, over 2 times a, which is 1. So negative 5 over 2 times 1 is 2. So x is equal to negative 2.5. Okay. So that means my axis of symmetry is at negative 2.5. So that's right here. So remember that's going to split my parabola in half. Okay, and then the next thing I need to do is find my vertex because I need to know where on this line is my vertex. So I know x is equal to negative 2.5, so I'm going to plug that in to the original equation. Okay, so I have 6 and 25. Whoops, I have negative 2.5 squared plus 5 times 2.5 plus 6, and negative 2.5 squared is 6 and 25 plus 5 times 2.5 plus 6, so that's 6 and 25 plus negative 12.5 plus 6. So 6 and 25 plus negative 12.5 is negative 6 and 25 plus 6, and that equals negative 25. So my vertex is when x is negative 2.5 and y is negative 25. Okay, so that's negative 2.5, and then y is negative 25, so it's about right there. Okay, so then I've got my parabola that looks like this. Okay, all right, and then the roots, these happen to be exact. Okay, right there, because we were able to factor. Okay, all right, number 10 says x squared plus 8 equals negative 6x. So first thing is we're going to write this in standard form. So I would add 6x to both sides. So I have x squared plus, I have x squared. I can't erase that. Okay, x squared plus 8 plus 6x equals 0. So let me rewrite that in standard form. X squared plus 6x plus 8 is equal to 0. Okay, so then we can go ahead and factor this. So we have the factors of 8 that add up to 6. So that would be 2 times 4. So then I have x plus 2 is equal to 0, and x plus 4 is equal to 0. Okay, so then I would solve by subtracting 2 from both sides. So x equals negative 2. Here, x is equal to negative 4. Okay, so I know that these are going to be the roots. It says solve each equation by graphing. If integral roots cannot be found, estimate the roots to the nearest 10. So these are going to be exact. Okay, these are your roots. X equals -2 and x equals -4. So since we factored, we didn't really need to graph that one out. Okay. All right. And then here talks about the transformation changes, the position or size of a figure. One transformation or translation moves the figure up or down or left or right. And then when the constant k is added or subtracted from the parent function, the graph of the resulting function plus or minus k is a graph of the parent function translated up or down. So basically it's saying you have the parent function that is centered at the origin. If you're adding a value k to that, if you're adding a value, you're moving that parabola up. And if it's a negative minus a certain value, then you're moving that parabola down. Okay? All right. And then if you have a value of h that is greater than 0, that's going to move your parabola to the right. If it's less than 0, it's going to move that value to the left. Okay? All right. And then it talks about dilations, the coefficient in front of x squared. If it's greater than 1, then it's going to stretch that parabola vertically. And if it's between 0 and 1, then it's going to compress it vertically. Okay? And then if you have a negative coefficient in front of x squared, that's going to flip your parabola. Okay? And then only positive coefficients in front of x squared give you that parabola opening upward. Okay, so number 22 says, which is an equation for the function shown in the graph? So I can see that my parabola is opening downward, so I know that my coefficient in front of x squared has to be negative. So I'm going to go ahead and eliminate 2x squared and x squared. So it can either be negative 2x squared or negative 2x squared plus 1. Okay, so this plus 1, remember this is the k value. So this is moving the parabola up from the origin 1 space, which is right here. So this is going to be the equation. This one here, it's centered at the origin, which this graph is not. Okay, all right. Next section talks about completing the square. Okay, so this is when you have in a perfect square trinomial in which the leading coefficient is 1, there's a relationship between the coefficient in the x term and the constant term. So that's when you take the value of b divided by 2 and square it, and then you add that to both sides. Okay. So any quadratic expression in the form of x squared plus bx can be made into a perfect square by using a method called completing the square. So what we do first is find 1/2 of b, the coefficient of x, square the result, okay, and then add that result of step 2 to x squared plus bx, okay? All right, so let's look at some of these. So number 23 says to solve each equation by completing the square round to the nearest 10th. So first thing I'm going to do is subtract 2 from both sides so that I have x squared plus 4x equals -2. Okay, so then I can complete the square here. So I need the value half of b, which is 4, and then squared. So half of 4 is 2, and 2 squared is 4. So I'm going to be adding 4 to both sides of my equation. Okay, so when I factor x squared plus 4x plus 4, I end up with a perfect square here, right? This is x plus 2 squared, and then -2 plus 4 is positive 2. Okay, so now what I need to do, I have the x plus 2 squared. Well, I just want to know what x is, right? So then I would take the square root of both sides. The square root of x plus 2 squared is x plus 2, and it equals the square root of 2, okay? And it can equal the positive square root of 2 or the negative square root of 2, okay? So I could write my answer as x plus 2 is equal to the square root of 2, or x plus 2 is equal to the negative square root of 2. So I need to solve both of those equations there. So here I would subtract 2 from both sides. So x is equal to the square root of 2 minus 2, which would be, when I round it off, about 6/10, okay? And then here I would subtract 2 from both sides, and I would get x is equal to negative square root of 2 minus 2. So x, you put that in the calculator, is approximately equal to negative 3 4/10. Okay? And those are my two possible answers there, or my two answers. All right, so let's look at the next one. Again, we're going to be completing the square. Okay, so first, I want it in the right form, so I'm going to add 5 to both sides, and I have 2x squared plus 4x equals 12. Okay, well, remember, my coefficient in front of x squared needs to be a 2. So what I can do is divide both sides of my equation by 2. So then I'm left with x squared plus 4x equals 6. Okay, so then I would need to take, not 4x, this should be 4x divided by 2 is 2x. Sorry about that. So it's x squared plus 2x equals 6. So then I need to complete the square. So I take half of 2 and then square it. So half of 2 is 1, and then 1 squared is equal to 1. So I need to add 1 to both sides of my equation. Okay? And then when I do that, I end up getting, I factor this side, x plus 1 squared, right, would give me x squared plus 2x plus 1, and then 6 plus 1 is 7. Then I need to take the square root of both sides here. So I have x plus 1 is equal to plus or minus the square root of 7. Okay, so I'll do that over here. X plus 1 is equal to the square root of 7, or x plus 1 is equal to the negative square root of 7. Okay, so then I'm going to subtract 1 from both sides. So x is equal to the square root of 7 minus 1. Put that in calculator, and you end up getting about 1 6/10. And then over here I would subtract 1, and x is equal to the negative square root of 7 minus 1. Put that in your calculator, and you end up getting about negative 3 6/10. Okay. All right. Then the next section I know is after the practice quiz, but you will have a problem like this on the quiz where you'll have to use the quadratic formula to solve a quadratic equation. So recall, this is the quadratic formula, this negative b plus or minus b squared minus 4 times a times c over 2a. So anytime you have a quadratic equation that you're trying to solve, you can just plug in a, b, and c into this formula, and then you have your solutions. Okay. So let's, this is an additional problem number. It's not on the practice quiz, but you will have one like this on your quiz. So we're going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4 times A times C all over 2A. Okay, so first thing is I have this 2x squared plus 9x equals 18. It's not in standard form yet, so I want to write it in standard form. So I have 2x squared plus 9x minus 18 equals 0. So now I see that A is equal to 2, B is equal to 9, and C is equal to negative 18. So I'm going to plug that information into my equation. So I have negative B, which is 9, plus or minus B squared, which is 9 squared, minus 4 times A, which is 2, times C, which is negative 18. The square root of that all over 2 times A, which is 2. Okay? So I'm going to follow my order of operations here and simplify. So I'm going to do exponents first. So this would be 9 squared, which is 81, minus 4 times 2 times negative 18. And then 2 times 2 is 4. So I have negative 9 plus or minus. And I'm going to do, I have 81. Negative 4 times 2 is negative 8. And then I still have to multiply by negative 18. And then I'm going to divide it by 4. So I end up with x equals negative 9 plus or minus 8 times negative 18 ends up being positive 144. And when I add 81 and 144, I end up with 225. And I'll just continue that over here. I get the square root of 225 is 15, well, plus or minus 15. So this would be negative 9 plus 15 divided by 4, or negative 9 minus 15 divided by 4. Okay, so I'm going to solve each one of those. So negative 9 plus 15 is 6, and 6 divided by 4 is 3 over 2, or 1.5, right? So x is equal to 1.5. And then over here, negative 9 minus 15, you add the opposite. That's negative 24 divided by 4. And negative 24 divided by 4 is negative 6. Okay, so x is equal to negative 6 and x is equal to positive 1.5. Okay, so I just plug in my a, b, and c value into my quadratic formula and use order of operations to solve. I get my solutions that way. Okay, all right. Thank you so much for watching. Hopefully this video was helpful. If you've gone through this whole video and you're confused about any of the problems, please make sure that you call, text, email me, or stop by my office hours and ask for help. I'm happy to help you, okay? And good luck on your test if I don't see you, and you have a great day.